If you tried to factor this, a is bigger than 1, and if you look at the answer choices, it clearly involves irrational numbers, so we're going to use the quadratic formula. So first we pull out what a, b, and c are equal to, then we plug in the values. A negative negative 7 comes out positive, so it rules out these two, plus or minus. And negative 4 times 3 times negative 1, I end up adding 12, so it's going to be this one, because 49 plus 12 is 61. So if you replace x with what it's equal to, it looks like this, which gives us this. I'm going to set it up for the box method, which gives me this, and here I have it solved for 0. Since we only need to know the number of solutions, we can use the discriminant from the quadratic formula. So that's the part that says the square root of b squared minus 4ac. And if it turns out positive, there's 2 answers. If it's 0, there's 1 answer. If it's negative, there's 0 answers. If you take the square root of 69 squared minus 4 times 8 times 98, that does come out positive, which tells you that there's 2 answers. First thing I'll do is I'll label a as 4, b as 6, and c as 1. I'm going to plug that into the quadratic formula. I can simplify this into 36 minus 16, and 2 times 4 is 8. This becomes the square root of 20 originally, and I can rewrite that as the square root of 4 times 5, and that allows me to pull out the 4, because that's a perfect square. So this becomes negative 6 plus or minus 2 root 5 over 8, and I can simplify this by dividing everything by 2, and this is my final answer, which is A. First thing I can do here is I can pull out a 2, and when I do that, this becomes 2 times m squared minus 8m plus 4 is equal to 0. If you tried to find the numbers that multiply to give you 4 that add to give you 8, it doesn't really work. So we can use the quadratic formula, where a is 1, b is negative 8, and c is 4. We plug in like this, which simplifies to this, and then this becomes root 48, which we can change to 16 times 3. Then we have 8 plus or minus 4 root 3 all over 2. If I divide everything by 2, this becomes 4 plus or minus 2 root 3. They want to know what is the sum of all the values. So 4 plus 2 root 3, 4 minus 2 root 3. If I add those together, these cancel out, and it's just 4 plus 4, or 8. T is a constant, and I want to figure out what equation or what value will make it have no real solutions. So I can subtract t from both sides, give me 2x squared minus 4x minus t is equal to 0. A is 2, b is negative 4, c is negative t. I'll plug this into the discriminant. That's the square root of, it's going to be negative 4 squared minus 4 times 2 times negative t. And for what value of t will this be negative? So if it simplifies like this, t is going to have to be negative. It's going to have to be less than negative 2, which the only one answer that fits is negative 3. You can't take the square root of a negative number, so there's no real solution. First thing I would do is factor out a 3. It's going to make all the math a little bit easier. Once you do that, can't really factor, so a is 1, b is 4, c is 2. Let's use the quadratic formula. Plug in like this, simplify 16 minus 8, that gives us 8. If I want to think in terms of perfect square factors, that's 4 times 2. So this comes down as negative 4 plus or minus 2 root 2 all over 2. And if I divide both of these, then I have negative 2 plus root 2, plus or minus root 2, which is A. For this problem, k and p are constants. I can double this to get rid of the fraction. I'm going to solve it for 0. So this is my equation. From there I know that a is 2, b is negative k, and c is negative 4p. I'll plug that into the quadratic equation, and it simplifies like this. Negative negative k just turns out as a positive k, and this part is k squared plus 32p. So if I split this, it's k over 4 plus or minus root k squared plus 32p over 4, which is b.